How can 3D printing create robot joints with integrated wiring? Imagine building a robot where the joints are not just moving parts but also carry their own electrical wires inside. Sounds futuristic, right? Well, thanks to advances in 3D printing, this is now possible. When making robot joints with integrated wiring, the key is combining precise design with special printing techniques. First, you design the joint with specific channels or cavities where wires can run. These channels are shaped to fit the wires snugly, preventing them from pinching or breaking when the joint moves. You can also include snap-fit or hinge-like features that make assembly easier. Next, using multi-hurried 3D printers, you can print with both rigid and flexible materials in one go. Rigid materials from the main structure of the joint, giving it strength, while softer, bendable materials create flexible conduits for the wires. This graded approach allows the joint to bend and move without damaging the wiring inside. For example, you might print a joint with a hard outer shell and soft internal channels where wires are embedded. Some printers can even print conductive materials or traces directly onto flexible substrates. This means you can lay down tiny copper or silver traces during the printing process, creating electrical pathways inside the joint. These conductive traces stay connected even when the joint moves through its full range of motion. In practical terms, designers create joints with internal cable channels where servo motors, sensors, or other electronic parts can be connected. During assembly, wires are clipped into these channels, keeping everything neat and protected. Using functionally graded materials, you can make soft sections that house wiring or actuators, while rigid parts provide strength and stability. Another approach is printing entire joint assemblies with embedded wiring paths, which reduces manual wiring and speeds up prototyping. This method also makes the final robot more reliable because there are fewer loose wires or connections that could fail. Overall, creating robot joints with integrated wiring through 3D printing involves smart design and the use of advanced materials. It allows for compact, lightweight, and efficient robotic parts that combine movement and electrical connectivity seamlessly. This technique is transforming how engineers and hobbyists build and test robotic systems, making complex designs more accessible and faster to produce.